Hey guys, today is March 11th and I'm gonna do another LeetCode Daily Challenge. So let's start. Yesterday's problem was pretty good. Hopefully today's is good as well. Even though we haven't hit a hard problem in a while, usually like I could do maybe like a 10% chance of doing a hard problem. So we'll see. Probably a hard problem soon though, but this one's easy today. Okay, maximum count of positive integer and negative integer given an array nums sorted in non-decreasing order. So that means strictly increasing? Yeah, that means strictly increasing, right? Return the maximum between the number of positive integers and the number of negative integers. In other words, if the number of positive integers in nums is positive and the number of negative is neg, then return max of there are 3 positive and 3 negative, so we just do 3. There are 3 negative and 2 positive, so we just do 3. Oh, this is this feels like almost silly, but I think it's just like a counting problem. Maybe we could just do positive count, right? And then a negative count. And then one thing to note here is that 0 is neither positive nor negative, so make sure we don't count that. So we just need to do this in linear time, like traverse from left to right for n in nums. If n is 0, it'll be like this. If n is less than 0, then we know that it's negative. Otherwise, if n is greater than 0, we know it's positive. I don't know why I didn't do this. There we go. And then we just need to return the max of the negative count and the positive count. That should be it. This is kind of a silly problem. Cool. Okay, I just saw something as well. So what I did was linear, right? It says, can you solve the problem in log n time complexity? So when I think of log n, without even like thinking more into this problem, whenever I see log n, that's immediately like binary search, right? Because binary search gives us log n. Okay. We actually might be able to use binary search for this problem. That's interesting. And what we can, the reason why we're able to use binary search is because binary search works it only works if the input is sorted, right? Or it works on sorted inputs. So let's just say that nums wasn't sorted and we had to do nums.sort. Well, that would not be good because that's an n log n time. But since we're guaranteed that nums is already sorted, we can just run binary search. Hey guys, so after I finished recording that video, I thought about it a little longer and without actually implementing binary search, because that's kind of annoying right now, I was just thinking like, I kind of want to know where I can place a -1, right? If I use Python's bisect right, which if there's a tie, like if there's already a -1, it will give us the index of where we can place it after. So, okay, so now that we know from 0 all the way to this index, that's how many that's how many negative numbers we had. And then for positive, it's where can I insert a 1, right? Because 1 is the first positive number and we want to bisect left. So it's going to also give us this, this like index right here, like at 3. And then we can do, obviously from 0 to the negative index, we don't have to do anything. But then if we want to take the length of the positive, we just take the length of the whole array minus the positive index. So that will give us 3. And then we just take the max of those. So before I submit that, because I don't know if that works, just to show you guys what I'm doing, I'll just print out the negative index and positive index. So like if we look at example 2, The negative index would be at 3, and then the positive index would be at 5, right? 0, 1, 2, 3, 4, 5. Like insert the 1 right here. So if we had a 1, 2, 3, 4, 5, 6, 7 minus 5, 7 minus 5 is 2. So we'd be comparing 2 with 3. And since 3 is greater, we're just going to return 3. That's why we do the max of these. So yeah, I don't know. Let me submit this, see what happens. Okay. Yeah, that's cool. So maybe that's cool. I mean, we now that I understand it, we can just code this up as binary search, but I'm gonna save that for next time. Yeah, it's pretty clean right here. Anyways, yeah, thanks for watching.